A repeated measures ANOVA is almost identical to a one-way ANOVA, except a repeated measures ANOVA has one factor with at least two dependent levels. Saying that the levels are dependent, it means that they share a variability in some way, that they have some kind of relationship to one another. And a repeated measures ANOVA, I will walk through the steps of my example. I invented a medication for depression called F2020. Before I can release this medication into the market, I must conduct a repeated measures ANOVA to determine if there's a shared variability and/or a significant difference implying this medication will work. I will measure the effects of this F2020 medication in 26 participants 4 different times over a 12-month period. This is because medications take weeks to months to kick in and change the brain's chemical imbalances. First, I will want to find the total sum of squares, mean, big N, little n, and G for each of the 4 groups in order to create a source table. In this case, I want to determine if there are differences between these 4 conditions using an alpha level of 0.05. Once I find this data, which I have displayed below, I can properly create a source table. On this slide, I have displayed a completed source table. Next, I will go through briefly of how to find each of these numbers. First, let's do degrees of freedom, beginning with degrees of freedom total, which is n minus 1. Next, degrees of freedom between is k minus 1. To find degrees of freedom within, you just subtract. Let's find the sum of squares. To find within, I will add up each group's sum of squares. Next, to find the total, I will take the formula of sum of x squared minus g squared divided by n. And then, once again, to find the between, I will just subtract. Next information we want to find is sum of squares between subjects, sum of squares of error, degrees of freedom between subjects, degrees of freedom of error. To find each of these numbers, I have provided formulas below. In our final steps, to find the mean of squares for between, we will take the between sum of squares and divide it by degrees of freedom between. We will then take that number and divide it by our error ns to get our f value. Now that we have completed the source table, we will take our f value and compare it to each group's mean to determine if there is a significant difference.